Great. Okay. So where did we stop in chemical bonds last week? Where did we stop in chemical bonds? Alamai? Yes, but I didn't send you the recordings of 6th and 8th lessons, no? So 6th lesson is already recorded. 8th lesson I have to record. I think I will do it tomorrow morning. And I think by tomorrow, during tomorrow, I will make sure to send the 2 recordings so that අපි quiz එක මුනොත් කරමු ඊට පස්සේ week එකේ. On 14th July, we'll do the quiz. Okay. So for the quiz also, quiz එක නම් already හදලා තියෙන්නේ. For the quiz also, it's going to be a little different this time. Because then first time අපි quiz එක කළා, we got some experience, no? So this time the quiz is going to be a little different. And I'll make sure to share the 6th lesson recording. I think Miss Divya, she can share it to you tomorrow morning. 1 second. Yeah. Okay, so tomorrow morning, she'll share the 6th recording and 8th lesson recording, probably afternoon, she'll share. So you have a week to watch both the recordings because they are anyway small lessons. So I don't think it will be very time consuming. So 14th of July, we can do the quiz. All right. So with that being said, so how was your week, Lamai? I couldn't ask you that. How was your week? Did you all have a great week, or was it an okay week, or was it a bad week? How was it? Others? Others, how was it? All right, term test timetable came. Okay. Anita Mukada, so don't worry too much. Just whatever we have done previously, make sure that you tighten that knowledge and you do a very good revision. And then 6th and 8th lessons also, you will get the recordings. And I'll try to send you 13th lesson recording. Recording I will send you. Reproduction, we said we are doing in the class, right? Then I think we are all good. Okay. So yeah. And others, anything interesting that happened in your week? No. Same here, actually. Nothing particularly interesting happened in my week. But I might have told you guys, we have a chocolate factory in Matara. So we had this big launch event this past weekend. So I was quite busy with that. So that was quite interesting. But other than that, I also had a very normal week. Okay. But at least I don't have term tests. So that's on you. Anyways, let's get to the lesson. I think where we stopped was we finished ionic bonds. And did I didn't give you any homework, right? Lots of people did come. So have you all heard of a place called the Good Market in Colombo? If you all are around Colombo, you may have heard of a place called Good Market. That is where it's like a Saturday market. And we launched our shop there. Otherwise, we have the factory already in Matara, but we launched a little stall or store there. It's quite a nice place, actually. It's in Colombo, like in the heart of Colombo. It's a Saturday market. It's very aesthetic and very cute. There are like so many different items, and also all those items are quite organic. So it was an interesting market. So apita teke podi stall la kamela. We also did a small launch event there. So I've been quite busy, yes, and just surrounded by chocolates the whole week. But yeah, kind of, not a lot, but kind of. So yeah, if you all are around Mathura, you can come and visit our chocolate factory, and I'll make sure that I give you free chocolates. Last batch ke Lame Kitya Mathura, I think he was quite nearby, and I even had a chat with his mother, but unfortunately we couldn't meet. But yeah, if you all are around Mathura, let me know. Anybody who's around Mathura or from Mathura? Name is, it's called Theolon. Theolon. It's called Theolon because we are making all Ceylon chocolates from like cocoa from Sri Lanka, sugar from Sri Lanka. So it's like an all Ceylon, all Sri Lankan chocolate, and it's very tasty. So yeah, if you all are, I'm a co-founder. I'm a partial owner. So it's a team of owners. But yes, so please do visit. You can give me a ring if you are around Mathura. Mathura tamai tiyenne. Mata call ekak dela, you can come. Okay. We have a lot of things there, and I can show you all of it. It's not like Willy Wonka's chocolate factory, but it's like a Sri Lankan version of that. Okay. So home atomic molecules, vela api karala tiyena fluorine, F2 molecule. And we have drawn the dot and cross, the Lewis dot diagram, and the Lewis structure. That's where we stop. Is that right? Is that right? එතනද අපි නැවැත්තුවේ. Okay. Then today, so that's the first example. Can you put number 2 and write O2 molecule? Write O2 molecule.
Miss, after Lewis structure, we have to write O2?
Yeah, so F2 molecule was the first example, right? Let me write on the board. So F2 was the first example, and O2 molecule is the second example. Okay. So, okay, so let's first, can you all tell me the electronic configuration of oxygen? What is the electronic configuration of oxygen?
2,6.
2,6, yes, it's 2,6. Then let's draw an oxygen molecule, sorry, oxygen atom. Okay, so then first energy level. Then, yes, Asheli.
Miss, when you like drawing these molecules, you just have to complete the outer shell, right? So, like for example, if we take like fluorine, since there are like 9, it's the atomic number is 9, so like 2, 8, 1, right? So like you have to complete the 1 or something like that.
Can you repeat the question again, Asheli? It wasn't clear to me. So if you take, yes, can you repeat?
So when we draw molecules, like in according to the Lewis structure and dot diagram and what is yes, according to them, you just have to complete the outermost shell, right?
Yeah, the outermost shell. We have to make sure that it becomes 8.
So like when you're drawing, you don't have to draw the first shell, then the second shell, just the outermost shell, right?
Yeah, for the Lewis dot and cross, the Lewis dot diagram and the Lewis structure, you don't have to. But the Mehem diagram you have to. But for those 3 diagrams, you don't have to. Okay.
Okay, miss. So we just have to draw the last energy level for Lewis structure and dot diagram, except for homoatomic molecules like that.
For home atomic molecules, dot and cross diagram, Lewis dot diagram, and Lewis structure. අර අන්තිමට අපි අදපු diagrams තුනට outermost energy level එක විතරයි බලන්නේ. දැන් අපි මෙතන ඩිස්කස් කරන්නේ කොහොමද මේක වෙන්නේ කියලානේ. ඒකට අපි energy levels ඔක්කොම ටික දාලා අන්දිනවා. But finally, for the dot and cross, Lewis dot and Lewis structure, we are only drawing the outermost energy level. Is that clear?
Yes. Thank you.
Okay. So I was thinking, since we already did F2, I would like you to give this a try on your own. I won't give you too much time because but use your pencil, please. I'll give you like 3 or 4 minutes. Can you all see if you can do this? Oxygen O2 එක කොහොමද හැදෙන්නේ කියලා can you all try to work it out? Try do this alone. So you know there are 2 oxygen molecules, right? Sorry, oxygen atoms. So දැන් මේවා electrons fill කරලා බලන්න කොහොමද combine වෙන්නේ කියලා. I'll give you like 3-4 minutes. Just try to see if you can figure it out. How's it going, Lamai? Were you able to figure out something? Okay, now I'm interested to find out. So I think that is enough time. Maugalanda perfect answer ka ganne ka neve expectation එක just for y'all to like maybe give it a try and see whether you will get an answer or not. ඒක හරිද වැරදිද වෙන්න ඕනේ නැහැ. So now I'll tell you how to exactly do this, right? දැන් බලන්න ඔයගොල්ලන් ලියපු එක හරිද වැරදිද කියලා. If it's correct, okay. If it's wrong also, don't worry. This is like you can learn from this because this is a little different. So O26 means first energy level, there are 2 electrons. And second energy level, there are 6 electrons. 1, 2, 3, 4, 5, 6. Here, 1, 2, and then here 1, 2, 3, 4, 5, 6. Then what happens is that may then set vela what do we call this kind of a pair? We learned this last week. What do we call this kind of a pair? What do we call this? We call this a lone pair. Right? තනියෙන් ඉන්න pairs වලට කියන lone pair කියලා. හැබැයි මෙයාට කෙනෙක් නැහැ. Right? Now this needs 1 electron. This also needs 1 electron. Then only it will become 8. මෙතන ගත්තොත් මෙතන මෙයා couple එකක් මෙයා couple එකක් no problem. But මෙයා තනියෙන් ඒගොල්ලන්ට තව electron එක ඕනේ. So what will happen is that මේ electron එක මෙයාත් එක්ක set වෙනවා. share කරනවා. මේ electron එක මෙයාත් එක්ක share කරනවා. So now it will look like something like this. Let's draw this. It will be something like this. So then ඔහොමනේ ඉන්නේ මේ දෙන්න. දැන් මොකද කරන්නේ? මේ දෙන්න electrons share කරනවා. So how would they share these electrons now? Their energy levels will overlap. They will come on top of each other. And it would be something like this. මෙන්න මෙහෙම එක උඩ එනවා. Okay? දැන් එක උඩ ආවම මොකද වෙන්නේ? Now what will happen when 2 electrons like this, they come on top of each other? They share electrons, right? So, මෙතන මෙයාගේ තිබ්බ එකයි. Move this a little towards this side. ඔන්න දැන් මේ දෙන share වෙනවා. So share වුණාම I will draw them at the middle like this. ඔන්න මේ දෙන share වෙනවා. ඒ දෙන විතරක් නෙමෙයි මේ දෙන්නත් share වෙනවා. But ඒ දෙන අඳින්න අපිට අමාරුයිනේ මෙතන. What we do is මෙතනින් අපි erase කළා ඒ දෙන්නවත් අපි මෙතනම share වෙනවා කියලා අඳිනවා. So now if you look at these 2 atoms, if you look at this one, first energy level has 2 electrons, second energy level has 1, 2, 3, 4, 5, 6, 7, 8. Okay? See, it's stable vela. If you look at this one, first energy level has 2, second energy level has 1, 2, 3, 4, 5, 6, 7, 8. Because Shaka never gone, they're not a mighty. So this has also become stable. This is how you draw the oxygen molecule. Is this clear to you, Lamai? Others? Okay. Then make a draw again. Can you all try to draw the dot and cross diagram? Make a dot and cross diagram. Lewis dot diagram and Lewis structure. Can you all try to draw these alone now? We already learned how to draw this. Quickly do, huh? Home atomic, then we can move on to heteroatomic. Make it fast. Did you all draw this? Dot and cross එක විතරක් හරි draw කරාද? ළමයි? Dot and cross diagram did you draw? Give me a thumbs up if you did. You have to respond. If you cannot respond, I would assume that you are just logged to the Zoom, but you're not really actively participating in the class. If you're not actively participating in the class, there's really no point of you participating in the class at all. Okay. So dot and cross. බලන්න මෙහෙමද draw කරේ කියලා. So we have මේ පැත්තේ oxygen එක මේ color එකෙන් draw කරන්න, මේ පැත්තේ oxygen එක මේ color එකෙන් draw කරන්න, so that I could show this to you. Inner energy levels okay, but outer energy level, let's see. මෙතන දෙකක් තියෙනවා, මෙතන දෙකක් තියෙනවා. Those are lone pairs. They are not participating in the bond, right? They are lone pairs. So මම එයාගේවා මෙහෙම dots වලින් පෙන්නනවා. And then මෙතන bond වලට participate කරන හතරෙන් දෙකක් මෙයාගේ. Two belong to this guy, right? So two belong to this. And then if you look at this one, මෙයාගෙත් here one lone pair, here another lone pair. And bond එකේ හතර දෙනාගෙන් දෙන්නෙක් මෙයාට අයිති. Okay, so let's draw that. But this time I will use crosses. Crosses like this. This is how you should be drawing the dot and cross diagram. Is this clear to you?
Miss, can't you use like dot dot cross cross for the middle part?
No.
Do they
You
have
have
to
to use
mix?
dot cross, dot cross. I මෙයාගේ කෙනයි share වෙලා first එක හදුනා. මෙයාගේ කෙනයි share වෙලා තව එකක් හදුනා. Okay, so then only it will seem like there are two bonds. Is that clear?
Yes.
Okay. Then Lewis dot diagram again, what happens is there are no crosses. Everything is dots. ඔක්කොම dots. Okay. So මෙහෙම තිබ්බට ඇත්තටම you can use the same color. මම colors දෙකක් use කරේ just to show you. Okay, this is a Lewis dot diagram. Then the Lewis structure is මෙයාව මම ගන්නම්. Lewis structure is the same as Lewis dot diagram. The only difference is the bonds are shown with a line. මෙතන ඔන්න මෙයාගේ electron එකකුයි මෙයාගේ electron එකකුයි connect වෙලා එක bond එකක් හැදෙනවා. So දෙපැති electrons දෙකක් ඇවිල්ලා එක bond එකක් හැදෙනවා. Like this. And තව මෙයාගේ electron එකකුයි මෙයාගේ electron එකකුයි connect වෙලා තව bond එකක් හැදෙනවා. So like this. This is how you draw the Lewis structure. Is this clear to you? Give me a thumbs up, please. Great. Now the next one you have to draw all alone, right? මේක නම් වරද්දන්න බෑ හැබැයි. Better you get this right the first time. N2 molecule. So this is nitrogen, nitrogen. Quickly draw this so that we could move on to heteroatomic molecules. So you have to draw how it is formed and then you have to draw the dot and cross, Lewis dot and Lewis structure. I will give you like, make it up 8 to 10 minutes again. Between 8 to 10 minutes, I will give for this. Make it really fast, quickly. Also, if you have any questions, please do ask. You can either unmute or you can use the chat box. Okay.
Miss, when we are writing according to the like O2 molecule, when we are writing two oxygens, do we have to use one like different colors for each of them?
No.
The same paint?
No. Mame different colors pen just for you all to get an idea. You better use the same color. See, this is how it's supposed to be. I was actually going to change the color. I forgot. Thank you for pointing that out. You better to use the same color. Okay.
Okay, thank you.
Yeah, okay. So N2 also do the same. Make it fast. Okay, I got 1 thumbs up. What about others? I think exactly 8 minutes passed. If you all need a little bit more time, I can give you 2 more minutes. Who needs more time? Okay, yes, I'll give you 2 more minutes. Okay, I think that's enough time now. I give you 3 more minutes. Did all of you finish? All right. So, what is the electronic configuration of nitrogen? What is the electronic configuration of nitrogen? Alamai? Hello. What's the, I will make switching on the camera compulsory if you don't respond now. I suppose you don't want that to happen. Can you all hear me? Give me a thumbs up if you can hear me. Okay, now tell me what is the electronic configuration of nitrogen? Hmm?
2 5.
2,5. So for all of you, it took so long to tell me the answer. It's pretty simple, no? Nitrogen, it's 2,5. Please don't take too much time and waste. Ogolangi answer is only in the question, right? So please do answer. Okay. So this is nitrogen. This is the first energy level. This is the second energy level. And we only need these two energy levels, right? So nitrogen, how it works is 2 and 5. 1, 2, 3, 4. මම 5 එක මෙතනින් දාන්න. මෙයාගේ first energy level එකේ 2, second energy level 1, 2, 3, 4, 5. ඒකත් මෙතනින් දැම්මා. So මේ දෙන දැන් couple එකක් විදිහට ඉන්නවා. මේ දෙනත් couple එකක් විදිහට pair එකක් හැදලා ඉන්නවා. So that's no problem. But බලන්න තනියෙන් කී දෙනෙක් ඉන්නවද? මෙයාත් තනියෙන්, මෙයාත් තනියෙන්, මෙයාත් තනියෙන්. මෙයාත් මෙතන තනියෙන්, මෙයාත් තනියෙන්, මෙයාත් තනියෙන්. So whoever is alone, they will bond. මෙයා මෙයාත් එක්ක bond වෙනවා, මෙයා මෙයාත් එක්ක bond වෙනවා, මෙයා මෙයාත් එක්ක bond වෙනවා. So it will be like this. So first energy level doesn't really matter because it doesn't change, right? But second energy level එකේ මේ තනියෙන් ඉන්න දෙන්න එහෙමම ඉන්නවා. මේ පැත්තේ තනියෙන් ඉන්න දෙන්න එහෙමම ඉන්නවා. මැද තුන් දෙනෙක් pairs තුනක්. They will be shared. 1, 2, 3, 4, 5, 6. Because this is the only way to show this, right? So then when we draw dot and cross, now I will use only one color to show you, right? So we have nitrogen, nitrogen. May nitrogen mama dots වලින් පෙන්නන්න, may nitrogen crosses වලින් පෙන්නන්න. So මේ පැත්තේ lone pair එකක් ඉන්නවා, මෙතන lone pair එකක් ඉන්නවා. ඊටු ඔක්කොම bond වෙලා ඉන්නේ. Dot cross and dot cross. Then in the Lewis dot diagram, මේකමයි, but everything is a dot, right? Everything is a dot like this. And then it's the Lewis structure. And that means there are 3 pairs, right? 3 pairs can අපි lines තුනක් තමයි දෙන්න. This is how you draw these 3 diagrams. Is this clear to you? Okay. 1 minute for recorrections and we'll move on to heteroatomic molecules. Make it fast. Quickly do the recorrections and let's move on. Lewis structure in this. Metan Lewis structure. Okay. So here can you see that Mea lone pair ekak, Meat lone pair ekak. And we know lone pairs we usually use dots to show. Right? That's all okay, right? Is that okay, Chalukya? That part? Okay. Then බලන්න මෙන්න මෙතන bond වෙද්දි. මෙයාගෙන් එක්කෙනයි මෙයාගේ එක්කෙනයි වෙල එක bond එකක් හැදුවා. Right? See this one. මෙයාගෙන් එක්කෙනයි ඇවිල්ලා එක bond එකක් හැදුවා. Like this. So that's what I showed with this line. Okay. Then මෙයයි ඇවිල්ලා තව bond එකක් හැදුවා. That's what I showed with the middle line. Then මෙයයි ඇවිල්ලා තව bond එකක් හැදුවා. Like this, and that is what I show with the bottom line. Balana, once we are done with making the bonds, let's look at nitrogen. Balana, main nitrogen, athur energy level, there are 2 electrons, no problem. Eliye, metana dennek inna. And we know in a covalent bond, shakar no koma dennata maiti. So metana dekai, 3, 4, 5, 6, 7, 8. See, got stable by sharing electrons. Same with this nitrogen. In the innermost energy level, there's 2. Then here 1, 2, 3, 4, 5, 6, 7, 8. They're right. So this is how nitrogen becomes stable. Is this clear, Lamai? Okay, great. I think that's enough time for the recorrections. Shall we move on? Okay. I think this we did under the topic homoatomic molecules, right? So now can you all please put a topic? Heteroatomic molecules. Heteroatomic molecules are molecules formed by 2 or more types of atoms. Now, if you take nitrogen, it's just NN, oxygen OO, then fluorine FF. But sometimes there could be different atoms bonding as well, like hydrogen and oxygen will form H2O. Nitrogen and hydrogen will form NH3. Carbon and oxygen will form CO2 likewise, right? So that is what we are going to learn here. So let's start with a simple example. So our first example is water molecule, which is H2O. So then අපි මුලින් බලන okay, there's 1 oxygen molecule and 2 hydrogen molecules, right? So I will first draw the oxygen molecule. First energy level, second energy level. I didn't draw circles this time. This looks pretty good, no? Enough. So oxygen wala, we know the electronic configuration is 2, 6. So 2, and then second energy level, there was 6. 1, 2, 3, 4, 5, and 6. Then if you draw, now there are 2 hydrogens, no? Micro hydrogen ekak draw karot. What is the electronic configuration of hydrogen, Lama? What is the electronic configuration of hydrogen? 1. Just 1. Then balanna, in this oxygen atom, methanol couple ekak inna. There's a pair of electrons, we call it a lone pair. Here also there's a lone pair. But methanol electron ekak taniyen inna. Methanol electron ekak taniyen inna. These 2 electrons only can form bonds. Then මොකද වෙන්නේ hydrogen එක්කෙනෙක් ඉන්නවනේ. මේ hydrogen එක්කෙනෙක් ඇවිලා මෙතනට set වෙනවා. අනිත් එක්කෙනා ඇවිල්ලා මෙන්න මෙතනට බොන්ඩ් වෙනවා. Like this. So මේ දෙන්න වෙනම බොන්ඩ් වෙනවා, මේ දෙන්න වෙනම බොන්ඩ්. That is what actually happens. So this is what we are going to have. මෙන්න මෙහෙම තමයි එතකොට ඉන්නේ. Give me a second, let me show you properly. This hydrogen මෙතන ඇවිල්ලා මෙහෙම overlap වෙනවා. So then oxygen ගේ එක electron එකක් හිටියා, hydrogen ගේ එක electron එකක් හිටියා. Now they are sharing electrons. Then this hydrogen will come and overlap here. So මෙතන එක electron එකක් ඉන්නවා, මෙතන එක electron එකක් ඉන්නවා. එක්කෙනෙක් oxygen ගේ, එක්කෙනෙක් hydrogen ගේ. This is how that bond is formed. Up to this point, is it clear? Now, let's see if this arrangement made oxygen or hydrogen stable. Then ඉස්සල oxygen තිබ්බේ 2 6, hydrogen ගේ තිබ්බේ 1. දැන් බලමු. දැන් oxygen ගේ first energy level එකේ 2 electrons, second energy level 1 2 3 4 5 6 7 8. There are 8 electrons. Then මේ hydrogen ගත්තාම both these hydrogens they have 2 electrons. 2 can is stable because you know helium also has 2 and it's stable. 2 is stable, 2 8 is stable, 2 8 8 is stable. Those are the stable configurations. So here oxygen is stable, hydrogen is also stable. It's a pretty good arrangement. Is this clear to all of you, Lamai? Okay, now let's see how I can draw the dot and cross diagram. Now, there are more than now. Oxygen එකනයි hydrogen දෙන්නයි ඉන්නවනේ. මම oxygen එකකින් පෙන්නලා hydrogen දෙන්නම තව එකකින් පෙන්නනවා. That means, let's say oxygen I will show with dots and hydrogen I will show with crosses. Okay. So, oxygen, may then oxygen gemai, may then not oxygen gemai, no problem. Then මෙතන share වෙන දෙන්නගෙන් එක්කෙනෙක් oxygen ගේ, here also share වෙන දෙන්නගෙන් එක්කෙනෙක් oxygen ගේ. So like this. And hydrogen. This is hydrogen. May share වෙන දෙන්නගෙන් එක්කෙනෙක් hydrogen ගේ, මෙතන share වෙන දෙන්නගෙන් එක්කෙනෙක් hydrogen. All right. So hydrogen like this and like this. So this is the dot and cross diagram. Remember, in this dot and cross diagram, dot diagram and whatnot, we only care about the outermost energy level. Okay, so keep that in mind as well. Is this clear, Lamai? Dot and cross is clear. Okay, then
Miss, shouldn't hydrogen come to the opposite side of the other side?
I don't know why that happens is because අපි feel කරන්නේ කොහමද? 1 2 මං කිව්ව පිළිවෙලට feel කරන්න. 3 4 5 6 oxygen. Yeah, එතකොට මේ දෙන්නට ගානට දෙක දෙක set වෙනවා. මේ දෙන්න තමයි තනි වෙන්නේ. That is why it's important to fill in the order. 1 2 3 4 කියලා එක round එකක් complete කළා තමයි ඊළඟ round එක අපි පිළිවෙලට complete කරන්නේ. Did you understand that part, Sasheli?
No.
Okay, so here hydrogen දෙපැත්තට එනවා නම් that would be something like this. So we have oxygen here. This is a nucleus. First energy level, there are 2 electrons. Second energy level, now there are 6 electrons, no? 1 2 3 4 5. Then 4 kilona එක circle එක round එකක් ඉවර කරා fill කළා. Then 5 6. එතකොට මේ දෙන තමයි මේ දෙන්නගේ දැන් already pair එකක් තියෙනවා. ඒතර මෙතනට තමයි අර හයිඩ්‍රජන්ට ඇවිල්ලා join වෙන්නේ. මෙතනට තමයි අනිත් හයිඩ්‍රජන්ට join වෙන්න වෙන්නේ. හයිඩ්‍රජන් දෙපැත්තට එන්න විදියක් නැහැ. එහෙම දෙපැත්තට යනවා මම fill කරන්න ඕනේ 1 2 3 4 then 5 and 6 කියලා මෙතන fill කරනවා. එතකොට හයිඩ්‍රජන් දෙපැත්තට එනවා. but එහෙම සාමාන්‍යයෙන් අපි එහෙම කරන්නේ we usually fill the electrons in the order. so මෙයාව 5 කියලා draw කරාට පස්සේ ඊළඟ ඉලෙක්ට්‍රෝන එක මම මෙතන draw කරනවා 6. Is that clear, Sasheli?
Yes, thank you.
Okay. Then Lewis dot diagram, what happens is there are no crosses, everything is a dot. So, see, my hydrogen gave a dot sitting in there. Simple, right? And finally, Lewis structure. මෙයාවම තමයි, the only difference is that bonds we will show using lines. දැන් බලන්න මෙතන එක ඔක්සිජන් ඉලෙක්ට්‍රෝන එකයි හයිඩ්‍රජන් ඉලෙක්ට්‍රෝන එකයි බොන්ඩ් වෙලා එක බොන්ඩ් එකක් හැදුවා. එහෙනම් here instead of showing it like this I can show with one line. And same here. I can show with one line like this. So this is how you draw the Lewis structure. Is that clear? Give me a thumbs up, Lamai. Good. Mama, now I told you, right, even though I showed using two different colors, just so you understand, you should not use two different colors when you're drawing, right? Usually you can use just one color. So I will convert this all to just one color so that this is how you're supposed to do it. Okay, great. Quickly draw this somewhere. Then I want you all to do something alone. Quickly draw. Page 179. අර angle කරලා තියෙනකද? Oh yeah, that's 179 is the angle one, right? Yeah, angle කරලා තියෙනක I will teach you in a bit. That is what I'm going to teach you in intermolecular bonds. So angled, the මේකත් ඉතින් angle තමයි. So it's the same thing. Whether you draw it that way, like it can make I mean, the molecule can stay in different shape. Sorry, different angles, right? So make if you rotate it like this, you get that particular angle. So it's the same molecule, different angles. Make මෙහෙම ලිව්වත් එකයි අර එහෙම ලිව්වත් එකයි. But අර shape එකෙන් තියෙන හරියට මම කියා දෙන්නම් in the intermolecular bonds part. But that shape is still this shape. There is no difference in the shape. Okay, Sashali? Is that clear?
Can you
Sashali, I didn't hear you.
explain again, please?
Yes. Now, this is the Lewis structure that we drew. But in the textbook, it's a different angle. හැබැයි ඒ මෙයාම තමයි. මේ දෙන්න එකම එක. එකම වෙනස තමයි මේගොල්ලෝ වෙනස් වෙලා. So ඔයා water sample එකක් වතුර ටිකක් ගත්තොත් එහෙම water molecules එක එක angles වලට ඉන්න පුළුවන්. මෙහෙමත් ඉන්නවා සමහරවිට මෙහෙමත් ඉන්නවා. නැත්නම් මෙහෙමත් ඉන්නවා එක එක විදිහට ඉන්න පුළුවන්. So in the textbook what they have given is this shape. But what I have drawn is this shape. මේක තමයි මම draw කරේ මේක තමයි textbook එකේ තියෙන්නේ but they are both the same shape at the end of the day. එකම එක කරකවලා තියෙනවා. Okay, so but usually අපි papers වල එහෙම questions වල අහද්දි මේ shape එක තමයි draw කරන්නේ. But ඒ shape එක ගැන අපි ඉස්සරහට කතා කරනවා. In the intermolecular bonds, we will be discussing more about that. Okay. I think you guys are still drawing, no? Anybody done? How long do you need? Hmm, 3 more minutes? Quickly. If you have any other, so good that you're asking questions, huh? Because others may also have had the same question. Others also let me know if you have any questions, huh? Done? Am I done? Or are you still doing? Okay, Ranmi done. Senudi done. Others? Tihansa done, Tharusha done, Anya done, Jevindu done. I think that means that was enough time. No? Shall we move on to the next one? When next time I want you all to do alone. Na? Mokata done on the next sticker. Number 2 is ammonia molecule. So, Lamai, ammonia molecule is, the chemical formula is something like this. NH3. Now, I want you all to try this alone. It will be a bit challenging because this is the first time you are trying something like this alone. But I want you all to give your best shot and see. Ek hari giyot kamak nahi, vadunat kamak nahi. Hari giyat vadunat, we are going to discuss. So some questions when I give you, I want you all to do it correctly. But some questions, I just want you all to try. Not exactly get the right answer, but if you get the right answer, good. Because we are anyways going to discuss. So do the ammonia molecule alone. Time make up 8 minutes. So you have to draw this entire thing and then dot and cross Lewis structure, all of those you have to draw. Yeah, I'll give you like 8 minutes. More time but I will have it here. I mean, I will keep an eye on the clock. Okay, chop chop.
Miss, do we have to write them, draw them to dot and cross Lewis structure, Lewis structure?
Yes, you have to draw those as well. Draw how it's formed, and then you have to draw dot and cross, Lewis dot and Lewis structure as well. Okay. Are y'all still doing or done? Then gone at 8 minutes. Okay, some of you are done. 2 more minutes. Okay, no worries.
Hydrogen, helium, methane, methane, boron, carbon, nitrogen, oxygen.
Done ළමයි? දැන් නම් ඇති නේද ටයිම් එක? කාටද තව ටයිම් ඕනේ? ළමයි? Shall we discuss? Okay, I think we'll discuss. Okay, so just to check what you all did. How many bonds are there in this molecule? Just to check if you all did this correctly. How many
3.
bonds are there? Okay, Sasheli says 3. Chalukya also says 3. Others, what do you all think?
3.
Senudhi also says 3. Shweta also says 3. Shweta says 4. Okay. Others, what do you all think? Any other answers? Excuse me for a second. Anita Manadaliwe. Okay, we'll see. We'll draw and see. So I told you, right? Haragiyat Vardunat, it's okay. All I wanted for you is to give it a try. Okay, Haragiyaho Varduna. I'm glad. It seems like all of you have tried this. Very good. Okay. So what is the electronic configuration of nitrogen? It's 2,5. Okay. So if I draw nitrogen like this, Let me quickly draw nitrogen. Nitrogen. So nitrogen has 2 energy levels and electronic configuration is 2, 5. So let me draw 1, 2. First energy level like a 2, second energy level like a 5. 1, 2, 3, 4, and 5. බලන්න මේ දෙන්න ඔන්න pair එකක් හැදෙන්න. We call this a lone pair. But here this is a lone. This is also a lone and this is also a lone. Okay. දැන් ammonia වල වෙන කවුද ඉන්නේ? Nitrogen ඉන්නවා, hydrogen 3 දෙනෙක් ඉන්නවා. Okay. So we already know how one hydrogen looks like. If this is the nucleus, this is the first energy level. Hydrogen වල එක electron එකයි ඉන්නේ නේ. So this is hydrogen. And we know hydrogen ge electronic configuration එක 1, nitrogen it's 2, 5. So what actually happens is that now here, as I said earlier, මේ දෙන දේ එකට එයා load back එකේ ගන්න කිසි ප්‍රශ්නයක් නැහැ. But මේ තුන් දෙනා තනියම ඉන්නේ. So hydrogen එක hydrogen කෙනෙක් ඇවිල්ලා මෙන්න මෙයාත් එක්ක එයාගේ electron එක share කරගන්න. Good. Then තව hydrogen කෙනෙක් ඇවිල්ලා මෙන්න මෙතනට ඇවිල්ලා මෙයාත් එක්ක electrons share කරගන්න. Like this. And another hydrogen will come and share its electron with this electron of nitrogen. ඔහොම තමයි ammonia හැදෙන්නේ. Okay. So let's see කොහොමද මේක වෙන්නේ කියලා. Let me redraw this again to show you how the bonds are actually formed. Okay. So මෙයා මෙතනට ඇවිල්ලා මෙයාත් එක්ක overlap වෙනවා. Now one electron belongs to nitrogen, one electron belongs to hydrogen, and now they're sharing those 2 electrons. Now the 2 electrons belong to both. Then this hydrogen comes here. One electron belongs to hydrogen, one belongs to nitrogen. Now they're sharing it together. And this hydrogen come here. And then one electron belongs to hydrogen, one electron belongs to nitrogen. They share. Now the 2 electrons belong to both. So then මේ nitrogen වගත්තොත් first energy level 2 electrons, second energy level එකේ here 1, 2. එශා කරන දෙන්නම යාට අයිතිනේ. 3, 4, 5, 6, 7, 8. See, that is stable, right? So now nitrogen is stable. Hydrogen ගත්තොත් බලන්න හැම hydrogen එකටම 2 electrons in. So hydrogen has also become stable. Up to this point, is it clear? All right. So now check if you drew the dot and cross diagrams correctly. Dot and cross diagram. So mama දැන් එක color එකකින් draw කරන්න දැන් ඔයාලා දන්නවනේ you all already have the idea. So I'm not going to use a few colors. I will just show you using one color. My order was different. How what do you mean different Chalukya? මේකම නිකන් angle එක වෙනස් වෙලා වගේද? If you could එහෙනම් කමක් නැහැ. මේක දැන් I mean so if you take this nitrogen main nitrogen නේ but දැන් මෙයා මෙහෙම ඉන්නවා. ඕගලන් draw කරපු එකේ මෙහෙම ආවනම් now let's say මෙහෙම තිබ්බනම් that's also okay. angle එක වෙනස් වුණාට කිසිම ප්‍රශ්නයක් නැහැ. That is also okay Chalukya. දැන් මෙහෙම තිබ්බත් කමක් නැහැ. Like this. ඔහොම තිබ්බත් කමක් නැහැ. Or even මෙහෙම තිබ්බත් කමක්. Angle changing doesn't really matter. As long as you have the structure correct, the angle doesn't really matter. Did that clarify what you asked, Chalukya? Perfect. So dot and cross. Now I will not use different colors. Mica color ekin pennanna. So nitrogen, we are only considering the outermost energy level. Nitrogen mama dots වලින් පෙන්නනනම් here there's a lone pair of nitrogen. And here මේ share කරන අයගෙන් එක්කෙනා nitrogen ට අයිති. So මෙතනින් එක්කෙනෙක් nitrogen ට අයිති, මෙතනින් එක්කෙනෙක් and මෙතනින් එක්කෙනෙක්. Then there is also hydrogen. The electrons of hydrogen I will show using crosses. This hydrogen has one electron shared, this has one shared, and this has one shared. So hydrogen ගේ electron එකක් මෙතන තියෙනවා. තව hydrogen එකක් and electron එකක් මෙතන තියෙනවා. තව hydrogen එකක් and electron එකක් මෙතන තියෙනවා. Then Lewis dot diagram. Here, sorry, same thing, but we just remove the crosses and instead of crosses, we put dots. But no change at all. Dot and cross එකම තමයි එකම එක crosses ටික අයින් කරලා එක dots දැම්මා. Like this. And then we draw the Lewis structure. Again, almost the same thing. Almost the same thing. මොකද වෙනස bond වෙලා ඉන්න අය එක line එකකින් පෙන්නනවා. Lone pairs dots ම තමයි. But bond වෙලා ඉන්න කට්ටිය දැන් මෙතන එක bond එකක් තියෙනවා. I'll show this using one line. And මෙතන bond එකක් තියෙනවා. We'll show using one line. Is this clear to all of you? Okay, great. Homework. Okay, so I want you all to draw a few dot and cross and these diagrams. So homework වලට draw the dot and cross diagram. Lewis dot diagram and Lewis structure for the following molecules. එතකොට මේ diagrams තුන අඳිද්දි ළමයි මේ diagrams තුන අඳිද්දි you also have to draw this. කොහොමද ඒගොල්ලන් හැදුනේ කියලා පෙන්නන diagrams තුන අඳින්න. Just like what we did here. So what are the molecules? Number one, carbon dioxide. Sorry. Hydrogen fluoride, which is HF. Then methane. Methane කියන්න ළමයි CH4. Methane is CH4. Then third one is carbon dioxide. And carbon dioxide you already know is CO2. Can you all do this for homework, ළමයි? පුළුවන්ද කරන්න මේක homework? Okay. මේක ලියාගන්න homework එක ඉක්මනට ළමයි. One second. Quickly write the homework.
Miss, do we have to draw them now?
No. This is homework. Did you all write the homework? The question. Okay. I think that is enough time. So let's move on to the next part because we have to finish the lesson today. Then අපි හැම වෙලෙම කියනවා නේද, in ionic bonds and in covalent bonds both, we say that always atoms form bonds, either ionic bonds or covalent bonds, to become stable, to get the stable electronic configuration. What did we say are the stable electronic configurations, Lamai? Noble gases well configurations like helium-2, neon it's 2,8, argon it's 2,8,8. May have noble gases well as electronic configurations sticker. These are our stable configurations. All atoms want this. Have more atoms bonds are than stable when. Remember in ionic bonds also, initially they were not stable. හැබැයි bond එක හැදුවට පස්සේ ඒගොල්ලන්ට මේ configuration එකක් ඇවිල්ලා නේද? Do you all remember that from ionic bonds? You all remember that from ionic bonds? Huh? Give me a thumbs up. Can you all hear me? All right. Do you all remember that from ionic bonds? Okay, so let me repeat the question again. Okay, listen very carefully. In ionic bonds, ඔයගලන්ට මතකයිද මුලදී atoms වලට තිබුණ එක එක configurations. Sodium has to weight 1, chlorine has to weight 7, magnesium to weight 2, oxygen to 6. එහෙම එක එක configurations නේ තිබ්බේ. හැබැයි ionic bonds ionic bond එක හැදුවට පස්සේ ඒගොල්ලන් හැමෝටම මේ stable configuration එකක් ඇවිල්ලා තිබ්බ නේද? After the bond, sodium got this, chlorine got this, then magnesium got this, oxygen got this. Likewise, before the bond, even though they did not have stable electronic configurations, after the ionic bond, they got stable electronic configurations. Do you all remember that? That was the question I asked. Others? Great. But it seems like only Ranmihi and Chalukya can remember because others did not respond. Again, Anita mataka nadda. E lesson eකට hitiye nadda because I remember during that day there was a pretty good attendance. That means did you come but were you not listening or what? Or you were listening but you didn't revise? Mokada prashne. Kuanita, Jevindu, Tarusha, Sasheli, Senudi, Dihansa, Anya, Ashani, are you a newcomer today? Ashani and Sanuti? Are you newcomers today? Can you let me know in the chat box whether it's your first day today? And Stephanie. Okay. Okay, Sanuti and Ashani, because Ashani, I think you are also new today. So just a little note, we are currently doing chemical bonds. And next week we will be doing reproduction lesson. So I'm sorry I couldn't properly acknowledge that newcomers were there in the class today. Okay. Then who are you? Okay. Ashani is my sister. Okay, got it. Better rename yourself. No, otherwise, Miss Deva, rename kara. 1 second. Natta Miss Deva attendance varadi loku prashnayak wena. Then she will mark you absent. That's why. But I will let her know. So no worries. I didn't revise it. Okay, so when you come to the class on a particular day, at least ඊට කලින් විනාඩි 5 10 හරි චුට්ටක් කලින් කරපු ටික පිටුව පෙරලා බා. I'm not asking you to like study 13 hours a day or like මෙච්චර hours ගානක් පාඩම් කරන්න එහෙම නෙවෙයි, but at least before the class and during the week also just take a few minutes. ඕගොල්ලන් හිතන්නේ ළමයි revise කරන්න ගොඩාක් වෙලාව යනවා කියලා. ඒකයි ඕගොල්ලන් ওই වැඩේ කරන්නේ නැත්තේ. You are not doing it because in your head revise කරනවා කියන්නේ නිකන් හරිම ලොකු දෙයක්, ලොකු වැඩක්. එතකොට ඒකට දැන් හිතන්න you have let's say 10 minutes. එතකොට මේක revise කරන්න 10 minutes වලට වඩා යයි කියලා ඔයගොල්ලන් ඒ වෙලේ ඒක revise කරන්නේ නැහැ. But actually ඉගෙන ගන්න තමයි ගොඩක් වෙලාව යන්නේ. Revise කරන්න යන්නේ චුට්ට වෙලාවයි. So once you learn this today in the class, if you revise it consistently, දැන් අද ඉගෙන ගත්තා නම් අනිද්දාට හෙට හරි අනිද්දා හරි පොඩ්ඩක් revise කරනවා. ආයෙ දවස් දෙක තුනකින් චුට්ටක් revise කරනවා. එහෙම revise කරද්දී it takes only a little bit of time. Because you already learned this and it's fresh in your memory. හැබැයි අද ඉගෙන ගත්තේ ඔයගොල්ලන් මාසයක් විතර you don't revise කියලා කියමු. මාසකට විතර පස්සේ පොත පෙරලා බලද්දී you can't remember most of this. එතකොට ඔයගොල්ලන් ආයෙ අලුතෙන් energy එකක් දාලා අලුතෙන් ඒකට time එකක් දාලා ආයෙ ඉගෙන ගන්න වෙනවා. So that's a huge waste of time. Right? So what smart students do, smart students කියලා වෙනම students කට්ටියක් නැහැ. ඕගොල්ලන්ම තමයි ඕගොල්ලන් හරියට smart විදිහට වැඩේ කරොත් you guys are smart. Okay, smart students කියලා there's not a particular category of students. Everybody is smart if you use smart methods. Okay. So rather than today learning and then ඒක දිහා බලන්නවත් නැතුව ආයෙ මාස දෙක තුනකට පස්සේ term test එකට දිගාරිනකොට you don't remember most නේ. එතකොට ආයෙ ගොඩක් time and energy and ඔක්කොම දාන්න වෙනවනේ. ඒක තමයි අමාරු. ඒක තමයි stress වෙන්නේ. එතකොට තමයි ගොඩක් overwhelming වෙන්නේ. හැබැයි අද ඉගෙන ගත්ත එක හෙට අනිත් වගේ revise කරොත් it will only take you 5 minutes. Just revise because now it's fresh in your memory. Revision doesn't take a lot of time. Revision doesn't take a lot of time. Learning is what takes the most time. Learning එක මෙතනින් කරනවා. එහෙනම් ඕගොල්ලෝ කරන revision part එක. That's the easy part. Revision එක කරන්නේ නැතුව ඒක මාස ගාණක් පල් කර ඉඳලා ආයෙ කරන්න ගියොත් revision නෙවෙයි. එතකොට ආයෙ ඔයගොල්ලෝ අලුතෙන් ප්‍රාම් කරන්න වෙනවා. So please keep this in mind. Because you don't want to continue being like this for a long time and then එකපාරටම අයියෝ අපරාධනේ මං හරියට කරා නම් කියලා හිතන එක නෙවෙයි වෙන්න ඕනේ. Right? O levels ලඟ වෙච්ච ගාම උගන්න නිකන් කඩියා කාලා වගේ you become like very flustered and like ඔක්කොම හරි කරනවා. එහෙම හරියන්නේ නැහැ. Okay? So O level ලඟ වෙදී ඕනතරම් ළමයි ඇවිල්ලා මට කියනවා parents ඇවිල්ලා කියන්නේ like they fall and they text and all that. තව පොඩ්ඩක් කල් තිබ්බනම් we would have gotten this right. And there are so many students over the past 7 years of teaching O-level students. ඒගොල්ලන් ගොඩාක් කියන දෙයක් තමයි අපරාධ grade 10 වල පිස්සු නැටුවානේ and grade 11 මුල කාලේ පිස්සු නැටුවානේ. ඒකෙන් මට ගොඩාක් ඒවා මිස් වුණා. මොකද ගොඩාක් ඒවා මිස් වෙලා අන්තිම කාලේ catch up කරන්න ඇත්තටම අමාරුයි. Right? ඒකින්ද ඒවා හරියම simple විදිහට මුල කාලේ ඉඳන් කරන්න පුළුවන් ඒක කරන්න. නැත්නම් අපරාධ, right? So it will be a waste. Then you will regret. Okay? So now දැන් මම කිව්වා ඔක්කොම හදන්නේ stable වෙන්න. හැබැයි there are a few exceptions. I will teach you about this, but can you first put the topic? නිකන් exceptions කියලා දාන්නකො දාලා අපි පොඩි sentences කීපයක් ලියමු.
Miss, is the topic exceptions?
What is it, Sashili?
Is the topic exceptions?
Yeah, the topic is exceptions. Okay. Mataka Maliyan Lamai, then we can save time. After writing, I will explain. For the moment, just write.
Miss, can you move up a bit, please?
Quickly write this, Lamai. After writing, I will explain this in detail. Puli liyagan note, make it fast. Okay, am I done? Did y'all finish writing? Or do y'all need more time? මොකක්ද මෙතන කියන්නේ? So as I said previously, all atoms make bonds ionico-covalent to become stable. That means to get the noble gas configuration. ඒ කියන්නේ helium වල configuration එක that is 2 or neon 28 or argon 288. ඒක ගන්න තමයි හැමෝම හදන්නේ. So එතකොට දැන් මෙන්න මේ 2 කියන එක නම් 2 කියන එක නෙවෙයි, but if you take 28 and 288, if you take these two configurations, they all end at 8. හැමෝගෙම outermost energy level එකේ තියෙන 8. So මේවට අපි කියනවා octet එකක් කියලා. When 8 electrons are filling the outermost energy level, we call it an octet. So that is what we say when the outermost energy level completes 8 electrons, we call this an octet. However, there are some molecules where the atoms, especially the central atom does not complete an octet. Let's first look at AlCl3. If you look at chlorine, make a chlorine මෙයාගේ කොහොමද electrons තියෙන්නේ 1 2 3 4 5 6 bond එකකින් electrons දෙන්න මෙයාට අතයි තියෙන්නේ. So 7 8. So chlorine octet is complete. If you look at this one 1 2 3 4 5 6 bond එකකින් දෙන්න මෙයාට අතයි තියෙන්නේ 7 8. Octet complete. මෙයාත් 1 2 3 4 5 6 bond එකේ දෙන්න මෙයාට අතයි තියෙන්නේ 7 8. So octet complete. Okay. So chlorine, no problem. But look at aluminium. Aluminium ke may bond ki na denna mein aata taiti because that is okay. So let me go again. Now if you take AlCl3, right? This is made with 1 aluminium atom at the middle and 3 chlorine atoms around it. So මොකක්ද bond එකක් හැදුවම වෙන්නේ the atoms become stable, right? They have to get either 2 or 28 or 288. 28 hari 288 hari ගන්නවා නම් that means we call it an octet. Let's look at AlCl3. අපි මුලින්ම chlorine atoms බලමු. දැන් bond එක හදලා ඉවරයිනේ. We will see if the electronic configuration is stable now. මෙතන තියෙනවා 1 electron, 2 electron, 3 4 5 6. There are 6 electrons already. And you know bond එකේ ඉන්න දෙන්නම යාට chlorine ටත් අයිති aluminium ටත් අයිති. So 6 මේ දෙන්නම chlorine ටත් අයිති ඉන්න 7 8. So now මෙයාගේ octet එක complete. That means it got a stable configuration. Is that clear, Sasheli? Okay. Other chlorines are also the same. 1, 2, 3, 4, 5, 6. May denna meata taiti 7, 8. 1, 2, 3, 4, 5, 6. May denna meata taiti 7, 8. Okay. So all of these, the octet is complete. Now let's look at aluminium. Metana may bond ke electrons දෙන්නෙක් ඉන්නවා ඒ දෙන්නම aluminium type. මේ bond එකේ electrons දෙන්නෙක් ඉන්නවා ඒ දෙන්නත් aluminium ට අයිති. මේ bond එකේ electrons දෙකක් ඉන්නවා ඒ දෙන්නත් aluminium ට අයිති. දැන් කවුද aluminium ට ඉන්නේ? 1 2 3 4 5 6. Only 6. That means has it become stable? Did it? So aluminium වල normal configuration එක 283. නේද? Then outermost energy level එකේ 3 නෙවෙයි තියෙන්නේ because now it has formed bonds. Then outermost energy level එකේ තියෙනවා 1 2 3 4 5 6. Now outermost energy level has 6 electrons. Is this still stable? Now stable. No. I mean the molecule itself it's unstable නෑ. එයා සාමාන්‍යයෙන් stable ඇත්තරම. හැබැයි යාගේ octet එක complete වෙලා නෑ. It has not gotten a stable configuration. එහෙම කට්ටියක් ඉන්න පුළුවන් කියලා තමයි අපි කියන්නේ. We say that all molecules they get a stable configuration, right? But there could be exceptions, and AlCl3 is an exception. So that is about AlCl3. Now if you look at PCl5, මෙයාගෙත් වටේ chlorine ටික අවුලක් නැහැ. They have gotten 8. Let's focus on phosphorus at the middle. Phosphorus වල usually electronic configuration එක 285.
So you're breaking about a bit.
So signal is okay, I guess. Can you all hear me now? Shall I connect to hotspot? Can you all hear me now? Okay, now it's okay. No, okay. So if you look at the second example, PCl5, central atom එක නැත්නම් මැද ඉන්නේ phosphorus. The electronic configuration of phosphorus usually is 285. Now let's look at this particular setup. දැන් මෙයා bonds හදලානේ තියෙන්නේ. Chlorine නම් අවුලක් නැහැ. අර වගේ තමයි chlorine වල stable වෙලා. No problem. Let's look at phosphorus. මෙතන electrons bond එකේ electrons දෙකක් ඉන්නවා. මේ දෙන්නම phosphorus ටයිපි. මේ bond එකේ electrons දෙකක් ඉන්නවා. දෙන්නම phosphorus ටයිපි. මේ bond එකේ electrons දෙකක් ඉන්නවා. දෙන්නම phosphorus ටයිපි. මේ bond එකේ electrons දෙකක් ඉන්නවා. දෙන්නම phosphorus ටයිපි. මේ bond එකේ electrons දෙකක් ඉන්නවා. දෙන්නම phosphorus type. So how many electrons does phosphorus have? Because you know in a bond, when electrons are shared, those electrons belong to both. Okay? So if we count 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. දැන් මොකද වෙලා තියෙන්නේ? outermost energy level එකේ 8 නෙවෙයි. Now there is 10. මෙතන octet එක complete වෙලා නැති ප්‍රශ්නයක් තියෙනවා. If you look at here, අපි මේ aluminium බලන්න, central atom එකනේ බලන්නේ. මෙතන aluminium ට වෙලා තිබ්බ ප්‍රශ්නේ එයාගේ octet එක complete වෙලා නැහැ. මෙතන phosphorus ට තියෙන ප්‍රශ්නේ එයාගේ octet එක exceed කරනවා. Now it has more than the octet. 288 නෙවෙයි 210. So that is also an exception. So most of the time when atoms form bonds, they become stable, they get the stable configuration, either 2 or 28 or 2810, they become stable. But there could be exceptions like this. Is that's the idea of this part. Is that clear to all of you? Is it clear? Great. Let's add a few sentences. May AlCl3 type, PCl5 type. Let's add a few sentences. May add a sentence clear. Here, the configure. May AI නෙවෙයි AL. Okay, it's not AI, it's AL. These are the two sentences that I want y'all to write. Make it fast. Okay, I think that's enough time to write. We can do a little bit more, so let's finish that part as well. Do you all remember we learned something called ionic lattice? අපි ඉගෙන ගත්ත නේද ionic lattice එක? I kind of remember that we last class was 30th, right? Yeah. Do you all remember learning the ionic lattice? Give me a thumbs up if you remember. Others? Great. So keep ionic lattice in mind. Now we are going to learn something called atomic lattice. This is a little different. මේකත් අපි ලියලාම discuss කරමු. එතකොට ලේසි අපිට, right? Let's quickly write and then we can discuss. මෙතනින් පස්සේ reproduction, pressure. මෙතනින් පස්සේ ඔක්කොම ගොඩාක් lessons වලට අපිට PDF තියෙනවා. ඒකේ අපිට අතරම ගොඩාක් time එක save වෙනවා. But chemical bonds නම් කොහොමත් I have never given a PDF because no point. There's so much to draw and write. ඒ කියන්නේ bonds අඳින්න ඕනේ, dot and cross diagrams අඳින්න ඕනේ. ඒකින්ද ඒකට PDF එකක් දීලා වැඩක් නැහැ. So ඒකයි ඒක අපි hand write කරන්නේ. But මෙතනින් පස්සෙන ගොඩක් lessons වලට there are a few without a PDF, but there's a lot with PDF. So that way we can save a lot of time. Okay, just letting you know that as well. Okay, so put the topic atomic lattice. Atomic lattice. I hope you're writing with me, Lamaya.
Can you move a bit up, please?
Yes, sure. Lamaya, please give me like 2 minutes. Mama, note clear, but while writing the note, I'll keep my camera off because my eyes are stinging a little because I was staring at the screen for some time. My brightness උට ටිකක් වැඩි කරලා තියෙන ඒකෙන්ද මම චුට්ටකට camera off කරනවා so that I could uh, just for a few minutes, huh? But I will be writing the notes, so you also write with me. We don't have to draw these structures. We just have to have an idea only. So let's write the note like this. Done, Ramay? Okay. So we have polarity, properties. So we have like about 15 minutes more of the lesson remaining, which we will do next week along with reproduction. So reproduction wala note එක completed කලින් batches වලට දීපු එකම තමයි ඔයගලන්ටත් දෙන්නේ. So I will ask Miss Divya to send that to the groups. She's actually not very well these days. මම හිතන්නේ ඔයගලන්ගේ ගොඩක් messages එයාට සමහරට miss වෙන්නත් ඇති. සමහර ඒවාට එයා reply කරන්නේ නැති. But the past few days, maybe like a week or so, she has not been very well. But I think now she's recovering, so she will reply to all of you and like me notes එවන ටික ඒ ටික එයා ගන්නට බලයි. සමහරට ඔයගලන්ගේ මොන හරි recordings ඉල්ලපු ඒවා තාම ඇවිල්ලා නැත්නම් ඒවා ආයෙ පොඩි reminder එකක් දාන්න chat එකේ. එතකොට මේ since she is back now, she can by any chance if she has missed your message, එයාට එතකොට ආයෙ එක බලලා එවන්න පුළුවන්. And 6th and 8th lessons, as I said, අනිවාර්යෙන්ම හෙට එවනවා. So එතකොට ඔයගලන් එක divide කරලා බලා ගන්න. If any of you are coming to the maths class also, because in maths also I'm thinking of doing some recordings. So you will have to manage. Okay, so එතකොට time manage කරලා දවසකට කොටස හරි බලන්න. 6th lesson එකට සාමාන්‍යයෙන් recording එකේ තිබ්බේ I think it was 2 hours or something. One second. Yeah. Yes, so 2 hours වගේ තමයි 6th lesson එක. 8th lesson එක නම් මං හිතන්නේ ගොඩක් දුරට තාම මම ඒක record කරන්නේ. I will record it tomorrow morning. I think it will be around 1.5 hours. So it's not like they are not very long lessons, long recordings. Then for the 13th lesson, that is something we will do next week. මම ඒක පුළුවන් වුණොත් මේ week එකේම එවලා තියන්න try කරන්න. මොකද කලින් batch එකකටත් මම කිව්වා වගේ recordings තමයි යවේ. ඒතර ඒ recording එකම ඔයගලන්ටත් එවන්න පුළුවන්. So I will check that. ඒකත් මම එවලා තියන්නම්. So in case you have term test, you can watch the recordings. So next week we will definitely be doing the quiz for the 6th and 8th lessons, right? I think that's about it. Do you all have any questions before we wrap up today? Or is everything clear? If everything is clear, just give me a thumbs up. Anya, Chalukya, Dihansa, Jevindu, Stephanie. Stephanie? All right. So Sanuti, since it's your first day within today and now today is over. So tomorrow you can let Miss Divya. Miss Divya is the one who probably texted you today or some other day. So you can let her know if you're continuing the class or not, right? So depending on whether you're continuing the class or not, she will coordinate the rest. I think that's about it, Lamai. We will be meeting next week on 14th of July. And yeah, until then, have a great week. I will send the whiteboard note as well. Good night, Lamai.
Good night, teacher. Thank you.
Good night.